The leap to quantum computing will take time, but there's no time like the present to start your journey. One path forward uses a quantum bridge by Spectral Capital to get the ball rolling. The idea is to prepare your organization's information architecture to tap into the imminent power of quantum. Learn more on this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
We're very excited to have one of my best friends in the business, one of the brightest minds I've met on the call today. There he is, Sean Michael Brehm of CrowdPoint Technologies and the Node Nexus Network. And by the way, he's also now the chief executive of Spectral Capital. So this guy wears a few hats out there. Luckily, all of these interests align. So CrowdPoint, Node Nexus Network, Spectral Capital, and Spectral in particular, it's a publicly traded company. It is focused on building a quantum bridge. I first heard this concept, I thought that makes a lot of sense because quantum is here, first of all, just to let you all know. There's been a lot of hype about this for a while. It is here, it is happening, but there is a tremendous, what they call in the business, impedance mismatch between the engine of quantum and basically everything else on the systems and applications side. And that is the chasm we have to get through here. And there are also financial chasms, there are organizational chasms, there are lots of different things that are in between the real world in which we all interact these days and the power of quantum computing. And I don't think there's a person on the planet who's better equipped to explain to us what all that means than Mr. Sean Brehm. So Sean, that's just my opening salvo here about where we stand. There is this tremendous power that some people are using today, but it's a very limited group. It's an elite group, I guess you'd say. And what you're trying to do is build a bridge which involves protocol, it involves algorithms that are quantum friendly. It involves basically building this bridge that will be able to connect that engine to our everyday lives. If you would just start us off on where we are now and what you think about all that.
Yeah, I think I could have said it better. I mean, at the end of the day, we know that the concepts of quantum computing and the kind of power that will provide us are going to have tremendous impact on us. It's going to impact security. It's going to impact what we think is artificial intelligence today. It's got such amazing potential, but in many ways, quantum computing is seen by many as being, not possible, too far out there. And you've got a lot of people, in the early stages. It's like the Oklahoma land rush. Everybody's kind of rushing out there. Some have got the right idea and they're moving towards, beyond Oklahoma and looking at the Rocky Mountains and then the Navaseradas and coming into San Francisco with the Pacific Ocean. They can see that far, but there's a lot of noise in this initial starting gun on quantum computing. And I think the biggest thing that people need to understand about quantum computing, it is here. The question is, you just can't run towards it. You kind of come up with a crawl, walk, run methodology. And so what we've been working at Spectral is to kind of create this quantum bridge. And part of that quantum bridge mechanism is the company is a publicly traded company that is a quantum incubator. So what that means is our job is to go out and find the pieces and parts of how we can take a look at existing technologies that are out there, ones that are a little bit ahead, and figure out how we can start creating that bridge between what we're seeing and many people would call the current web technologies or the current Internet of Things or the current analytic approaches and bridge them to quantum computing. And for us, you're the data guy. It's been about data since day one.
Mm-hmm. And there's this concept too, and I love this concept. It's a real world thing, a flywheel. A flywheel comes in very handy for a car because it captures energy in the middle and it sort of attenuates and allows everything on either side to work. And that's kind of what you're trying to build here, right? Is a flywheel slash bridge in between this tremendous power of quantum computing and all the applications and systems and things that we do in the real world. Is that a fair assessment?
Yeah, 100%. And then you have to figure out what the starting point of that is. What's the initial marker of that flywheel? Where's everything lean on. And as a data guy, it's data. I mean, data, many people say is the new oil. So if you look at, the way the world works today is much like oil refineries. You take this crude out of the ground, and then you got this oil, and then you get petroleum engineers and you refine it, and then some is really high grade, and that goes to power, rocket ships and top secret jets, and then you've got really crude stuff, and even down to stuff like petroleum coke that powers big huge industrial plants, from dirty to super clean. And so what you have to look at when you get into quantum computing is quantum computing gives us the ability to exponentially refine data into information, because information is really what powers the global markets. So you've got to look at quantum computing as a mechanism by which you can more efficiently, refine this data from many different sources with the velocity, the variety, the veracity problems, variability. But the key is, how do you extract the value out of it faster and more efficiently? And that's what quantum computing, if you break it down, that's really what quantum computing is here to do.
Yeah, and just to explain to people, so traditional computing, we all understand, most people understand, is zeros and ones. It's actually, if you get right into the weeds, it's really above and below a certain threshold, and below it counts as a zero, above it counts as a one. But the point is, you got two options. And so if you look at a lot of the work that's been done over the last half century in computing, one could argue that a tremendous amount of effort has been built around trying to reconcile this binary view of the world with the non-binary, to use a weird word of the day,
It is a
reality
little
around us, right? So we
Yeah.
live in an analog world. It's not a digital world. And even digital, like I'm suggesting, really is analog with a sort of superimposed structure on top of it, which is the zeros and ones.
Yeah.
But so much effort has been built around trying to reconcile the shortcomings of binary with the analog reality around us. And of course, quantum uses qubits. And maybe you could explain that just so people understand, because a qubit is like a quantum bit, and it could be in what they call a superposition representing 0, 1, or both simultaneously. And this
Correct.
is what I heard from an expert I talked to a few months ago, who says it's not just four directions. I thought it was four. He's like, no. It's any number of directions. And that is central to why it is so powerful at being able to refine the oil you're talking about. Can you just explain that?
Yeah, 100%. You nailed it. First of all, qubits, that's the building block of quantum computing. And it's capable, really, the thing that's mind-boggling, existing in multiple states simultaneously.
Right.
So that's kind of like, that gets into beam me up, Scotty kind of stuff, right?
Right.
And so when you look at that versus the binary of it is or it isn't, you get into multiple states, and it is, and you're looking at, concepts that are just, it can be lots of different things at the same time. And then you brought up a great word, superposition. And a superposition enables those qubits to perform many calculations at the exact same time. And then once you get beyond those two mind-boggling concepts, you have to look at the concept of entanglement. So entanglement
Mhm.
is a quantum phenomenon where qubits become interconnected. This allows for instant information gathering. So what I would really say, it really allows for instant data surfacing, and you get into really interesting things with governance, lineage, and provenance at lightning speed. And then that gets you to a new kind of information sharing. And then when you look at quantum gates, that means that we can now have multiple and things that can manipulate those quantum states, enabling computer computations. So data can be an information can be held in many different forms and do many different computations. And then you get into the gates themselves, the quantum gates that allow you to manipulate those qubit states, which is really interesting. So now you look at, initial analytics surfaces this summary. That summary gives you the idea to identify some kind of connectivity with another one. You can surface hard, soft, and absolute rules really fast. So now you can combine soft rules and then you can quickly remove those that are soft and start moving into absolutes. So that concept, once you get into the quantum gate, means you've got to start getting into these additional concept called quantum gates.
Hmm.
And those quantum gates get you into quantum algorithms. And quantum algorithms, that's where the sauce, that's the refining of data. That's where specialized algorithms that leverage quantum mechanics that we just talked about for better problem solving. And then that gives you entrance into quantum speed up, which is the ability to solve those problems faster. Then the benefit, the part I love the most is, especially a world where we're sitting at $11 trillion in cybercrime. Now you have the added component that kind of wraps around that, and that gives you quantum security. And that's this advanced encryption methods that protect data from cyber attacks. And then it gets even faster with the advent of decentralization. All of these concepts you and I have been bumping around for the past 2.5 years, and quantum computing really has kind of given us that 8 kind of step framework on how to operate within.
Yeah, and in my research too, I'm just finding all sorts of other interesting concepts. There's this concept of interference, right, where different qubit states can interfere with each other either to constructively reinforce or destructively cancel out. And apparently, this allows quantum computers to amplify correct solutions and suppress incorrect ones. Can you talk about that for a second?
Yeah, so when you think about it, this really gets into some concepts you and I have talked about before, which is the concept of entropy, right? If you don't know what wrong is, how do you know what right is?
Right.
And so I remember, I won't say the name of the company that's really big that a lot of people use to search. I was with some engineers one time, and we were talking about these learning dictionaries, and I said, well, what I don't understand is, they're like, you use our dictionary, do you use our libraries? I said, no, I've run some entropy on them, and I've seen some issues associated with that. And this was in Salt Lake City, and I go, entropic models, and the guy looks at me and says, well, I took like a quarter of that in college. So when you start getting into quantum computing, those concepts of entropy in real time allow you to really get into something a friend of mine said years ago when we were working together on projects inside the intelligence community. He said, look, really, really good technology gets to the point where data can find the data and the user can find the relevance. So when you start talking about the concept that we're talking about here, it's about providing relevance, but not only relevance, but the correct relevance. And that's kind of sums up the benefit of this construct.
Yeah. And entropic models, I mean, if I understand them correctly, with these large language models, were designed to open up the potential of what the answer could be, because they're trying to, I suppose, reflect the creative nature of the world around us, right? They're trying not to be so precise, but in opening that gate, they also open the door to hallucinations and to other things of this nature. Because to your point, if there's no North Star, actually, one of my good friends from ExxonMobil had a great point. He goes, we have to stop letting these things pattern recognize their way to the truth.
100%.
There needs to be a truth, and then you gravitate toward that. That's what you use regression models for and things of this nature, to see, okay, are we online with the truth according to the truth we know?
Yeah.
Right. But these entropic models are just pattern recognizing. So if you get enough bad data in your system, if it's trained on enough bad data, it's just going to give you really, really bad answers, right?
Yeah, well, I think there's 2 aspects for it. If you don't know what wrong looks like, you never know what right looks like. But your point about the North Star is really good. One of the major problems you get in these large language models is, as you ask it a question and it's surfacing possible answers, it kind of hallucinates because it gets lost.
We wanted to talk about node, nexus, network, and this decentralized network. So some people are starting to wake up and figure out what all this decentralized stuff really means. And it does mean finding a path that is not so contingent upon one center to hold it up. So if you look at Amazon Web Services, you look at Microsoft Azure, you look at Google Cloud Platform, these are centralized platforms. Now they have distributed architectures underneath, but it is one company, one choke point to a certain extent through which everything goes to get stuff done. And with a decentralized network, and correct me if I'm wrong here, Sean, but you have folks all over the world now, thousands of people who are part of this network, and their computers will spin up an instance and then connect to the rest of the network. But the point is, they are individual stacks all on their own. So it is truly federated. If you think about the DARPANET, which I'm sure you, or ARPANET or whatever, which was the foundation of the web, one of the key concepts was decentralization, so no one can take out the whole network with one node being taken down. That was the whole idea, is to have a resiliency in terms of information transfer. And now you're taking that concept through Node Nexus Network to build the pillars of a blockchain, but it's also marketplaces on top of that blockchain. The point being, it's truly decentralized, and thus there's no choke point. There's no one string someone can pull to take this whole gosh darn thing down, which, let's face it, whether it was intentional or accidental or whatever the hell just happened with CrowdStrike, you just saw a third roughly of the information systems in the world brought to their knees, all because a file was loaded into the BIOS of these machines, and a little driver that was already there went to read this file, but it was a nothing file. It was a do not touch me file, pointed to bad memory, as I understand it. So that's just an example of the dangers of a centralized architecture, right? So tell us a bit about Node Nexus Network and how it's different and how it fits into this whole equation.
Yeah, it's, when in past shows, you and I have been talking about the concept of decentralized computing, and at CrowdPoint, we've been working on a distributed quantum ledger database, which is, exactly what it means. It's decentralized and distributed. It provides a quantum ledger, which means the data within it is quantum proof, it's quantum speed enabled, and then it's also a database. So I got on the road and started selling, and I'm over in UAE, and I found a company, a bunch of guys from Ras Al Khaimah and from Dubai that were putting together an edge and hybrid cloud strategy. And I said, well, you need to really consider a distributed and decentralized quantum ledger database. And after walking them through the quantum ledger database, they're like, wow, this is pretty compelling. This is truly quantum ready, because you collapse the application layer and the data layer and the compute layer into one. And this really is going to be kind of, and they actually the ones that said this is going to be a bridge to quantum computing. It's going to be the foundation. So as we started talking and selling the concept, they kept looking at me going, hey, we got a great CEO here. Can you come on board and we're going to rename the company, and we want to create this whole other opportunity here with you, and the company's called Node Nexus Network out of UAE, and the idea was take a traditional approach to edge and hybrid computing, which is got a massive total addressable market, in the trillions, and it's got a huge potential. So now what happens if you now federate those, as you said, across 16 global regions and 251 nations, where it's 5 shipping containers, 3 containing, server racks in them for about 1,500, providing about 1,504 servers, a NOC, and then you got an entire 40-foot container that's filled with batteries for the hydrogen power, and then you power the whole thing with solar panels on top and wind, and now you've got the sustainable edge compute environment that also has quantum capabilities that doesn't touch the grid. So you got this really sustainable model. And that's really what drove it. As I was going here, I came to Switzerland. I was talking to some guys about, doing a $100 million bond to do it, to help grow this as chairman, using some relationships. And we're in Zug, and all of a sudden I meet some guys that have been looking at quantum computing, and they're like, whoa, this is really compelling. We're looking at some really interesting things and on doing crazy things with graphene and creating graphene fields and doing some really interesting things at the cellular structure of bacteria and graphene. And next thing you know, they're like, hey, you got a pretty strong vision. You got a great way of, taking this quantum ledger technology and then decentralizing it and not impacting, the current infrastructure. And that's going to be needed for quantum computing. Would you mind kind of come on the board of this publicly traded company and then after a month or so, they said, come on board as a chairman. So essentially, our Quantum Bridge program is literally this. The value proposition is simple to CEOs out there. How would you like to save 40% off your current hosting? Immediately engage in an edge and hybrid cloud strategy in which all your data can be moved into a distributed and decentralized quantum ledger database, which leverages BLS 12381 and Sphinx Plus 64-bit security to literally make your data immutable. You can create these coalitions where at a snap of a flip of the wrist, you can create cross correlations with no APIs, and at the same time, it's all in a JSON format that kind of lets you build your own ontological language models. Now you can go to market with your own personalized AI. And one of the demos we showed was taking, the old a database that was very similar from an old company, very similar to Blockbuster, and started showing what happens. And you can have a conversation with a legacy database. And that's what's exploded the vision. And so what we're doing now with our Quantum Bridge program is like, look, we got a great program for you to get into quantum computing, start at a distributed quantum ledger database, put it out at the edge, leverage a solid edge hybrid solution. We've got this integration module that gets back into the centralized. So if you want to make sure you can still maintain your analytics in a centralized place, but you can save 40 to 50% off and then migrate your company to your own version of an authentic intelligence. And when you take that authentic intelligence and you interconnect it with your supply chain or your business ecosystem, you're creating what MIT calls a collective intelligence. And that has really just has me on the road 24/7 today.
Wow.
People are responding really well.
Yeah. And yeah. I mean, there are lots of different aspects of this to dive into. And I did want to touch on some of the material science involved here. And you kind of hinted at some of that. In UAE, there's this project where they are using, maybe you could explain a little bit what that's all about, because again, the wafers you have to create the new chips, for example, to create next generation chips. Can you talk about the material science under that? Because that's from the UAE too, right?
Yeah. So when you look at a lot of, UAE always had some pretty good lineage. And I think, honestly, there's some initiatives you're going to be hearing about, not announced by me, but I have insight to them. I think you're going to see a new kind of Silicon Valley emerge out of UAE. And when you think about it, Taiwan is problematic. The U.S. has really moved a lot of out there, and these guys are thinking beyond the current problems. I mean, you get them in a room and they're like, Sean, this is if we're going to get to quantum computing, it's a gamma light problem. And those of you that understand how chips work, patterning today of chips happens through a process called photolithography. And essentially, what you have to look at as a Pentium chip or any kind of computer chip is a microtized version of Venice. There's lots of canals, and so the problem is when you use light today to pattern that, you're at 0.35 times 10 to the negative 18, and you can't. There's no more light to pattern it even smaller. So now you've got this huge, massive problem. How do we solve patterning independent of trying to move qubits through a canal that is this wide, that needs to be the width of my fingertip, actually the nail of my fingertip? And that's one of the biggest problems. And so what they're looking at is, well, let's start using some really interesting science. Let's start creating graphene fields. Let's start looking at bacteria. Let's start looking at splitting mitochondria. So I think what you're going to see is really low energy, super fast ability to build these new kind of chips that doesn't require a fab that cost you $1 trillion. And I think that's what's really exciting about what we're starting to see in UAE.
Well, and so to kind of get back to the bridge concept here and the flywheel that I was talking about, you have all these component parts. You have the quantum power, which is tremendous, but we need to be able to figure out how we're going to fuel this thing and how we're going to build the next generation of hardware. And to Sean's point, some very interesting things are happening in that space. And you do have to think way outside the box to use this. But again, where along the line are you going to be able to capture and store energy, then be able to distribute it to the rest of your architecture? Because we're talking about an information architecture. If you get right down to brass tacks, this is all about information architecture and access to appropriate data at the appropriate time to do the appropriate things, whether that's a transaction or an analysis of something. And what's cool about this quantum stuff is it can do all kind of stuff at the same time. And your quantum ledger database also has flattened the different component parts, which were artificially separated in the first place. If you think about it, and this gets back to my opening comment, that the zeros and ones and that whole mindset about how compute needs to be architected is being challenged now, and there are different ways to do that. So you don't have to separate out the analysis. I mean, we've had this for years too. There's in database analytics, there's in database AI, there's all the kind of stuff you can do architecturally, but how efficient is it compared to what you could be doing? And that's what you're focused on with this quantum bridge, right? Is building out the component parts that will essentially become a flywheel for the power of quantum, right?
100%. I mean, if you look at the current big data models, you and I have grown up in them. You had you had to take data out. You had to establish this landing zone. So you had to extract the data. Then you had to transform the data into some kind of common schema. And then you had to load that data. And then you could start running analytics on it. When you start getting into the superpositioning we talked about, and the quantum, the qubits being had in multiple states, now all of a sudden you've got all these possibilities of what that data could mean in persistence. So in the end, as long as you can basically create a semi-structured model with objects and arrays, which I think every 16-year-old kid in the world can use a JSON file, and you take the data that you don't want to share and you leverage technologies that are 64-bit capable of being quantum or quantizing data. Now all of a sudden you can commingle, your first name, middle name, last name, date of birth, social security number, and quantize it along next to all the financial transactions you've made with your credit card. Index those transactions against the same global industrial categorization standard that Wall Street uses. And now what you've done is, it comes to the crux of the vision, is you're able to return more value to everybody, because the human identity, which is the life behind the oil, is operating at the intersection between commercial and capital markets, and quantum computing is going to really flip it. Because as you know, right now, everyone listening to this call works in the commercial markets. They're buying handbags, they're buying a banana, they're buying ice cream, they're buying an automobile, and all of those are happening in the markets, guessing. And at the end of the day, your data is in a database, and then that's stolen by some 16-year-old kid in Moldova that does a SQL injection and sets trillions of dollars in cybercrime. What happens when you're the custodian? You're in custodial agent of your own data. Wow, you start getting paid for being you, and you've got a much more efficient model fusing commercial and capital markets, which pays for this tech. And the value of having a quantum compute capability with all these multiple states, looking at multiple individual authentic intelligences and assembling them in real time to kind of a collective intelligence. Not my idea. MIT's been saying this for years. That's when this idea of quantum computing becomes less a pie in the sky. And we're seeing it today. I can literally, we already created this whole model, and I can show you examples of, one ontological model colliding with another ontological model. You can ask it an obscure question like, who's the best president in American history? And he goes, I don't know who they are. Because in that coalition of data, it doesn't have outside ability to talk to everybody. And then you've got another coalition that maybe the history of the United States. So when you combine the two, now all of a sudden you've got this collective intelligence. No need for APIs, which are really easy to hack. Custodianship is tied to the right person, and you've got this really efficient model. And you're to see massive disruption in the industry. What happens to all your middlware application? What happens to all these RDF frameworks and all these things, these rigid concepts that we've had to follow? You get it. It's just mind-boggling. And to the average person out there, like, Sean, I understand the words you're saying. What you should understand is, if data's the new oil, and you've got quantum as the best refinery on the planet, you're going to get more accurate. You're going to provide new discovery. And at the end of the day, it's going to provide a great quality of life for all of us that engage in this new way of computing.